All right, today we're going to look at the theorem of intersecting lines. The first thing you must know is that whenever two lines intersect each other, when I mean intersect, I mean they cross each other. So let's say we have a line this way, and then we have another line this way. When they cross each other, an angle will be formed, right? So we have an angle, 360 around the lines. So whenever two lines meet, regardless of the type of line, whether perpendicular lines or any kind of line, once they cross each other, angles are going to be formed. But when we're talking about theorem of intersecting lines, it's not just any type of line. The line we are referring to is parallel lines, or rather are parallel lines. So when we're talking about theorem of intersecting lines, we're talking about parallel lines. Parallel lines are lines that travel in the same direction, and hence they can't meet each other. So let's say we have two parallel lines. So this one going in that direction. For another line to be parallel to it, it has to travel in the same direction, and parallel lines are indicated by an arrow. So you see the arrow pointing the same way. Now when these two lines are traveling in the same direction, they're said to be parallel. So you see that they are not intersecting yet, so we can't have any angle. But then if we can draw a straight line that cuts these two parallel lines like this straight line is called a transversal. So this straight line that cuts across two parallel lines is called a transversal. So whenever this transversal cuts these parallel lines, then we can begin to talk about theorem of intersecting lines, because you agree to me that angles will be formed also 360, around the parallel line. So these angles that will be formed, there are relationships, specific relationships between them, and that's what we want to look at in this video. So let's talk about the first one. So I'm just going to redraw this, to get a cleaner diagram. So remember, we have our arrangement again. We have two parallel lines and then a transversal. We say that there are angles that will be formed. So the first relationship in all these angles that are formed is, the first one is what we call corresponding angles. So that's the first one. We're saying that corresponding angles are always equal. So corresponding angles are always equal. So your problem would be how to identify a corresponding angle. Okay, how I like to understand, how I like to see this is that corresponding simply means the same position. All right, the same position. This is just a way to remember. So when we mean the same position, look at what we mean. So relative to the this first parallel line, let's consider this angle. So I'm just going to color one angle there. This angle here, for instance, you see that it is on the first parallel line. Okay, let's label these parallel lines. Let's call this line A, B, and let's call this line C, D. Now you see that this angle I just shaded is on the line AB. Which side on the line ABC is on the left, top left, right? So you see that that angle is on the top left of the line AB. That's where the angle is. We're saying that the corresponding angle to that will also be on the line CD, top left also. So this one also would be equal to that one. So you see, that's why I'm shading them the same color. They are equal, and the reason for that is what? Corresponding angles are equal. So when you hear corresponding, that's what we mean. So that angle there, see, top left AB is corresponding to what? Top left CD. Now let's draw another corresponding angle. What if I shade this one, this angle here? Which one is corresponding to that? Can you guess? The angle that is corresponding to this one, you see, this is on the parallel line AB. It is on the bottom right. Do you see that now? Bottom right. Okay, let's try that. So this is bottom right. So the angle that will be corresponding to it will also be the angle on the line CD, bottom right. So that will be the same. They will be the same size. So that's why we call them theorem of intersecting lines. What if we shaded this angle, this one? Which angle will be corresponding to that one? You see, that is top right on the line AB. It will be corresponding to the one also top right on the line CD. All right. So and then the remaining two unshaded angles are also corresponding. So you see the angles in the same position are going to be equal, and the reason is that corresponding angles are equal. So one thing you must notice is that we're not just guessing these things. I said that for these things to hold, it must be a parallel line. We have a pair of parallel lines and then a line that is cutting across the parallel lines, which we call the transversal. So whenever I have that kind of relationship, then these laws are going to hold. So I believe corresponding angles are very clear. Move on to the next one. Alright, so we have our setup again. Remember, these are parallel lines and then the transversal. The next relationship you want to know is that vertically opposite angles are equal. So vertically opposite angles are always equal. Okay, so this one is very easy because when we talk about opposites, it simply means, the way I like to remember this is they are going to be facing each other directly. Facing each other directly, alright? So let's share some angles. Again, let's label this AB. So this will be AB as well, and this will be CD. Okay, so this angle here, if I shade this angle, so which angle is vertically opposite this shaded angle? Because vertically opposite angles are always equal. Now, the angle that is vertically opposite it is this angle also. You see that they are directly facing each other. So we call them vertically opposite angles and they are always equal. So just to put numbers to it, let's say that this angle was 60 degrees. Then this will also be 60 degrees because vertically opposite angles are always equal. Okay, what if we shaded this angle here on the line CD? Which angle is vertically opposite it? It would be this one. See, they are facing each other, so vertically opposite angles are equal. So if this angle was 30 degrees, this would also be 30 degrees. Also, this angle and this angle are vertically opposite. This angle and this angle are vertically opposite. So this is the second relationship you should know, that vertically opposite angles are always equal. So let's do the next one. So we have our setup again. The next one you want to know is that alternate angles are equal. So that's the third one for today. Alternate angles are equal. Alright, so let's identify the alternate angles. So again, we're going to call this line AB. We're going to call this line CD. Now let me shade one angle. So look for the one that's alternate. Now let's shade this angle. So we want to identify which angle is alternate to this, because they must be equal. Now, how I like to remember this alternate is right, against left. So an angle on the right will be alternate to the angle on the left, but we are taking now relative to the transversal. That's the special thing you need to take note of. These angles are going to be referenced from the transversal. Remember, our transversal is the straight line that is cutting or running across the parallel lines. So relative to this our transversal, you discover that this angle is on the left, right? So let me just write that. You see, relative to the transversal, I mean this straight line, this angle is the left. That's the left. So this angle, the right, is alternate to it. So we just share that. So the angle that's alternate to that will be this one, and they're equal. All right. So if I share the other part, this side, for instance, the angle alternate to it would be this angle. So they might not look equal because I didn't draw this according to scale, but they're always equal. That's alternate angles. So one thing you must know is that alternate angles always form something like a Z, right? So if you see a Z and you see that these two lines must be parallel, so this angle here will be alternate to this angle here. That's how it works. If I extend this line, this angle here will also be parallel if I extend this line. I mean alternate rather. So alternate angles form something like a Z, alright? So that's how to remember it. Alternate angles are always equal. So we'll go over to the last one. That's the last relationship you should know, at least for now. And that would be So we just bring back our setup again. The last one is that interior angles, or rather, let me say interior angles are supplementary. So you must know that. But before we go ahead to identify interior angles, you must know what we mean by supplementary. Supplementary angles are angles that sum up to 180. So that's what I mean by supplementary angle. For instance, if I give you 100 degree and I ask you what is the supplement angle of 100 degree, I'm asking you what angle will I add to 100 to give 180, and that should be what? 80 degrees, because 100 plus 80 is 180. So that's what I mean by supplementary angles. The another one you need to know is complementary. I'm just digressing, but I think it's imperative to understand. Complementary, on the other hand, are angles that sum up to what? 90 degrees. For instance, if I give you 50 degrees, the complementary of 50 degrees will be what? 40 degrees, because 50 plus 40 will give you 90. So, but what we're saying in this case is that two interior angles are going to be supplementary. Now, let's identify what we mean by that. Let's say we have an angle here. So let's share this one. So when we mean interior angles, actually we're talking about these angles. Let me just shade all of them. These angles here, right? Kind of inside the parallel lines. These other ones are not excluded. So I'm going to shade the exterior angles with pink. So take your eyes off these angles for now, right? So the interior angles are the one that I'm shading with lemon color, right? So take note of that. So let me just get rid of it again. Okay, so I have that angle there, and then I have this angle here. So you see that I'm not shading two of them with the same color, meaning they are not equal, right? There's no relationship for them. They are not corresponding. They are not alternate. They are not vertically opposite, but they are just two opposite interior angles, right? So there are two interior angles. So we are saying that they are not equal. Rather, we're just saying that, okay, let's call this A and let's call this B. We're saying that if you do A plus B, you must get 180 degrees. So that's the reason, or rather that's the meaning of two interior angles are supplementary. We mean that if you add the both of them, you're going to get 180 degrees. That's what we're saying. Okay, so what if you have other angles here? This is C and this is D. Also, C and D are not equal, but we're saying that if you do C plus D, you should get 180 degrees, because two interior angles are supplementary. So if you know all these theorems that we've gone through in this video, you should be prepared enough to solve questions on angles. And if you've not watched the first video I posted on angles, where I tried to mention all the angles, acute angles, reflex angles, obtuse angles, try to identify all of them. So also do well to watch that video. I'm going to drop the link in the description of this video. And also, I'm going to also drop the link, because after this one, we're going to now use the knowledge of everything we've learned to solve real questions. So I'm also going to drop the link I'm going to drop the link to the playlist of everything you need to know on angles. So we're going to be hopefully proficient in tackling questions that have to do with these relationships and anything angles. So I hope